Hi guys, so today we're going to be doing geometric series. Before we get started, let's just look at the definition again and how the formula is derived. Okay. So we already talked about how a series is the sum of a sequence. Okay. And so a geometric series is just the sum of a geometric sequence. Okay. So the formula here is quite similar. Right. So here it's the sum of the first 8 terms. Okay. Right. So here's the first 8 terms. And then here it's subtracting 3 of that sum. Right? And so basically what it does is it takes this and it moves it over. Right? Because 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27. So when it multiplies 3 times that sum, it now moves it over. So that way there's a first term and now an additional term here. Okay, and so that's how we get the formula. Sum 1 minus first term in series minus that last term multiplied by the common ratio divided by 1 minus that common ratio. Okay, and so this is kind of how it's formulated. Right, so it multiplied by 3 because that was the common ratio, and then what it does is it moves each term over 1. Okay, so that way when you subtract it, now you're only left with the first term and then the negation of the last term times the common ratio. Okay. So that's how we get the formula, right? So note here, first term minus what would be then the last term, okay, times the common ratio over 1 minus r. Okay. The ratio can't be 1 because if not, it's just 1 plus 1 plus 1 plus 1 plus 1 plus 1, or whatever that first term is plus itself again and again. Okay. So that's why the common ratio can't be 1 and we can't use the formula here. Okay, so let's get started with example 1. Okay, so here it says contagious diseases can spread very quickly. So suppose 5 people are ill during the first week of an epidemic, and each person who's ill spreads the disease to 4 people by the end of the next week. We want to know by the end of the 10th week of the epidemic, how many people have been affected by the illness. Okay? So we're going to be using the sum of our terms equals the first term times 1 minus the common ratio, n, right? So without doing the n minus 1 thing, then we get, because the n minus 1 gives us the previous term, or the last term, right? But then we want to multiply the common ratio times that last term, so we're going to remove that minus 1. Okay. Over 1 minus r. Okay. So here, we want to know the 10th week, right? We want to know by the end of the 10th week, and so that's going to be in place of n. Okay. We know that there were 5 people who are ill during the first week, so that's a sub 1, right? So that'll be here at a sub 1. And then we know that they're spreading it to 4 more people, right? Spreads the disease to 4 people, and so that will be our R. Okay. So S sub 10 equals, first term is 5, and then 1 minus common ratio is 4 to the 10th power over 1 minus 4. Okay. We're just going to simplify. This will be negative 3. 1 minus, okay, 4 to the 10th power is 1048,576. Okay, big number. Continuing up here. So minus that, minus 1048,575 all over negative 3. Yep. I'm going to multiply these together and then divide it. So 5 times negative 1048,575 divided by negative 3. And that gives me 1747625. So 1747625. So let me put comma so we can see that. So how many people have been affected by the illness? 1,747,625 people. And there you go. Okay, so why don't you try CYP1, and then once you're done, come check the answer. Okay, you should have gotten 1,023 dominoes. If you got that right, you can move on to example 2. If not, here is your explanation. Okay. So we know that she knocks over the first one. So in the beginning, there's only one domino, right? That's in the first row. So that's why that's A sub 1. And then each domino knocks over 2 more dominoes. So that means there's a ratio now of 2. And so that's why 2 here is in my common ratio. There are 10 rows. And so that is n here. So plugging in. Okay. 2 to the 10th power is 1,024. 1 minus 1,024 is negative 1,023 times 1 is still the same. Divided by negative 1 gets rid of the negative. So that's why it's 1,023 dominoes. And there you go. Okay, so now let's do example 2. So now we're using sum or sigma notation, right? Again, this here is sigma. It's the Greek letter for sigma. Right? Here we're evaluating a sum written in sigma notation. Okay, and so what you can notice is that this is a geometric sequence, right? Okay. So this here is first term. Right? This here, you know, is the ratio, or R, common ratio, right, in the n minus 1. And here, because it wants to go to first to 6, it makes it easy, and we can use the sum formula, right? So if it's first to 6 terms, it's the sum of the first 6 terms equals first term, which is 5, 1 minus our ratio, which is 2, and then we want first to 6 terms, so that's why it's 6 here, all over 1 minus 2. Okay, so that's one way if it works out with our numbers. Okay, and so in this case it does, right? It's a sub 1, r to the n minus 1, and we want from first term to 6 terms, so that's why we can use our sum of 6. Okay. So this comes here. Right? If it was 2 to 6, then this wouldn't work. Okay? Or if it's 3 to 6 or something like that. It has to be 1 till whatever. Okay? And then here, it has to follow a sub 1 and r. Okay. So then now let's simplify. 2 to the 6th is 64. This becomes negative 1. Running out of space here. 1 minus 64 is negative 63 over negative 1. So really, the negatives cancel, and then it's just 5 times 63, which gives me 315. So there you go. That's my sum. Right? The other way you can do it is you can do it similarly to how we did it for an arithmetic series, right? And then just keep plugging it in, right? So plug it in for the first, then the second, then the third, then the fourth, then the fifth, and the sixth, and then add it all together, right? And so that's where you see in the book, that's what they did in terms of method 2, right? So you can do it where you plug in 1, then 2, then 3, then 4, then 5, then 6, right? And then simplify here, add it all together, you still get the same thing. Okay, so either way works. Okay, you would do method 2 if it didn't follow this pattern, if you couldn't do it that way. Okay, so why don't you try CYP2, and then once you're done, come check your answer. Okay, and there you go. Either way, you should have gotten negative 484. So this also is a geometric sequence written in this way, so you could also use just the sum of geometric series. Okay, or you just plug it in from first term to fifth term. Okay, so again, this doesn't always work, right? If I wanted third to the 8th term, you would have to do it this way rather than this way. Okay, but because it goes first to fifth, and this is a geometric sequence where you can find a sub 1 and r, then the geometric series formula works. Okay, so now let's move on to example 3. So here we want to find the sum of a geometric series for which the first term is 15,625. One of the terms is negative 5. We don't know which one. And then the common ratio is negative 1/5. Okay. So first we need to figure out which term this is. Oh, actually we don't. So here we're going to use the different formula, okay, where we don't have to know which term it is. Knowing which term it is with the other one. Okay. And so this formula is S sub n equals a sub 1 minus a sub n times r all over 1 minus r. Okay. And you can see where this formula is derived from above, on top of the book above example 3. Okay. So here we want to find the sum. Okay. So we're going to plug in what we know. Okay. We know that the first term is 15,625. We know that this term is negative 5. And then we know that the common ratio is negative 1/5. Okay. So plugging in what we know. So S sub n equals first term, so 15,625, minus our other term, negative 5, times the common ratio, which in this case is negative 1/5, all over 1 minus negative 1/5. So all I did is plugged in. And so now we just need to simplify. Okay. So negative 5 times negative 1/5 is just 1. So this will be 1,506.25 minus 1. Okay. Then 1 minus negative 1/5 is 1 1/5, also known as 6/5. Okay. This will be 15,624 divided by 6/5. Okay. So if I want, I can change this to 1.2, or I could also use dividing fractions. Keep the first fraction, flip the second one, so 5 over 6, and then multiply. Okay, so 1,564 times 5, times 5, divided by 6, and this gives me 13020, 13,020. Okay. If you changed it to 15624 divided by 1.2, right, because 6/5 is 1.2, you would get the same thing. And there you go. So why don't you try CYP3, and then once you're done, come check your answer. Okay, you should have gotten 1,875. If you got that right, you can move on to the last example. If not, here is your explanation. Okay. So again, we're using the formula where all we need is the first term, another term, and the ratio. Okay, and that's the formula here. So I know the first term, a sub 1 is 1,000, so I plug that in for a sub 1. Okay. I know that one of the terms, the last term in this sequence, is 125. So then I'm plugging that in for a sub n. And then I know the common ratio is 1/2. So that's plugged in for r. Okay. Half of 125 is 62.5. I decided to do it as a decimal because I didn't want to deal with fractions above and below. Okay. And then 1 minus 1/2 is 0.5, right? It's also 1/2. Okay. 1,000 minus 62.5 is 937.5. Divided by 0.5 is 1,875. There you go. Okay, so now moving on to our last example. Okay. So here we want to find a sub 1. Right? And then based on what we are given, that will determine which sum formula we're going to do. Okay, so here, since there's no a sub n, I can't have two unknowns, right? I can't not know a sub 1 and a sub n. So as a result, I'm going to use the other formula, which is s sub n equals a sub 1 times 1 minus r to the n over 1 minus r. Because I know that this is here, that's what the sum is. I know what the ratio is. And then here, since this is s sub 8, I know that n is 8. Okay? And then all I need is to find a sub 1. So only the yellow here in this case will be my unknown. So plugging in what I know, the sum of this series is 39,360. I'm going to find the first term, so it's going to stay as it is. Okay. 1 minus common ratio is 3. And since this is the sum of the first 8 terms, my n here is 8. And then 1 minus 3. Okay, and then now I'm going to solve. Okay. So this is going to stay as it is so far. Three to the 8th power is 6,561. 1 minus 3 is negative 2. Okay. So since this is dividing by negative 2, I'm going to change it to multiply. Okay. So 39360 times negative 2, let's continue up here, is negative 78,720. And then 1 minus 6561 is negative 6560. Okay. And then since these are being multiplied together, I'm going to do the opposite, which is to divide. And that gives me 12. So my first term in this geometric series is 12. Okay, so why don't you try CYP4, and then once you're done, come check your answer. Okay, you should have gotten 6 for your first term. If you got that right, you can get started on homework. If not, here is your explanation. Okay, so we're given the sum of the 7 terms. Okay, so that's why I plug in that sum 258 for s sub n. Okay. I'm finding a sub 1, so that's just going to stay as a sub 1 until I find it. Okay. R, the common ratio is negative 2, so negative 2 and negative 2. Yeah. And then here, since this is the sum of the first 7 terms, n here is 7. Okay. Then I did negative 2 to the 7th, which gives me negative 128. Okay. 1 minus negative 128, that'll become plus, so that's 129. I got rid of the divide by 3 by multiplying by 3 on both sides. Okay, and so 3 times 258 is 774. And since this is a sub 1 times 129, divide by 129 on both sides to get a sub 1 by itself. And so 774 divided by 129 is 6. So a sub 1 is 6. That's it for today. Have a great rest of the day. Bye, guys.